All right. So yesterday we did linear transformations in the form f of x. Oh no, it was not f of x, it was g. So g of x, your new function, equals a times f of x. And it was called a vertical stretch or compress, so a vertical transformation, because the a is being multiplied by what? The x's or the y's? The y's, because f of x is the same thing as y. So if you multiply all of the y's by a, some number, that means you're stretching it out. You're making all of the y values bigger. If I make all the y values bigger or smaller, that's a vertical change, a vertical compression or stretch. So in yesterday's examples, you might have already written this down, but some of the other classes didn't write it down. A is multiplied by the y's. So if you don't have that on your paper, write that down. Today we're going to be doing the opposite. When you are multiplying a by the x's, then it's a horizontal stretch or compress. All right. So in at the front page of your notes, halfway we'll start today's notes. So type 2 is a horizontal stretch / compression. Using function notation, this looks like g of x equals, and instead of the a being on the outside, it's now on the inside of the parentheses. So f of ax. So here, we're multiplying all of the x's by a. So multiplying x's by a. And that means that if you have a line and you're multiplying the x's by a number, then it's going to change left and right, which is horizontal, because the x's go left to right. So now I'm comparing it to the y-axis, how close or far away it's getting from the y-axis now. And we'll see when we start looking at examples on the graph that whenever the a is in the parentheses, it actually does the opposite thing that we would expect it to. So the first situation is if a is bigger than 1. Remember yesterday we started off by saying that if a is bigger than 1 or if a is between 0 and 1. So if a is greater than 1, then g of x is a horizontal. I'm going to actually try to move this. A horizontal, and you would expect to say stretch, but it's not a stretch, it's a horizontal compression. The horizontal compression looks like a vertical stretch. It's going in the opposite direction. So horizontal compression by a factor of, remember we're talking about the opposite things here. So if the a is, for example, 2, you know what, I'm just going to edit the video and just delete this part. I'm not starting over. Hello. Okay, gotcha. Okay, they're so quiet. My other classes would be like dying. Like cracking up. Okay. Here they're just cracking up inside. All right. Back to where we were. So anyways, remember what I said about if a is in the parentheses, then it works the opposite way. So actually, the factor is also the opposite. So what would be, for example, if a was 2, what's the opposite of 2? By opposite, I actually mean the reciprocal. So you know what the reciprocal of 2 is, Fisher? 1/2. So reciprocal of 2 is 1/2. So if you have a, the reciprocal of a, we would write as 1 over a. So the factor for horizontal compression and stretch is whatever the value of a is, you take the reciprocal of that. So 1 over a represents the reciprocal. So parentheses, reciprocal. Okay, let's look at an example. So here's your example. F of x equals x minus 1. And your new function g of x is f of 4x. So 4 is greater than 1. First step is we are going to find what the new g of x function is. So instead of what we did yesterday we multiplied the entire equation by 4. Today we're only multiplying the x by 4. So if I have g of x, I'm going to take f of x, x minus 1, but instead of x, I'm going to replace it with 4x. So 4x minus 1. Notice that the y-intercepts stay the same now. So on your graph, you'll see the y-intercepts stay the same, but the x-intercepts change, which was the opposite of what we did yesterday. So what I want to do is I want to go onto Desmos. So go ahead and open up your Chromebook. Go to desmos.com. Have you guys ever used Desmos? And then the graphing calculator. So the first one, in the first line, you type in y equals x minus 1. On the second line, type in y equals 4x minus 1. You type in the two equations, y equals x minus 1, and then y equals 4x minus 1. If you want to look, you can look at the board. I have it written there. So my first line is, I'm going to make this line blue because I think that's what you have. Oh, wait. Go to the graphing calculator. Desmos graphing calculator. Okay. So if you look at the red line is the original one. Don't zoom in. If you need to go back, just click on the home button. See this home button right here? If you're zoomed out on accident, just click that. So here's my red line. According to what we learned yesterday, having a steeper slope if it looks like that, then we said that stretched it vertically, but that's not actually what we're doing here. Instead, we're moving the points closer to the y-axis horizontally. So we're doing a horizontal transformation. If I take this and I push all the points this way, that would mean it's a compression. See that? It's being compressed horizontally closer to the y-axis. So actually having the A being 4 does the opposite when we're looking horizontally. It compresses it, not stretches it. And if you look at the points, so for example, when the x is 2 here, it's 1/2 here. It's getting 4 times closer to the y-axis. If x is, let's pick another one, 4, this x is at 1. So it gets 4 times closer to the y-axis. If you try to compare it vertically like we did yesterday, it doesn't work that way. So like this point, 1, 1 times 4, you would expect it to be up at 4, 1, 2, 3, 4, and it's not. So it doesn't work vertically like the ones were yesterday. This one works horizontally. It's sort of compressed. So that's why it's a compression. So go back to your notes and write down the description for this one. So G is a horizontal compression by a factor of what? What would be your factor here? Fisher? 1/4, 0.25, yeah. So 1/4. And then let's take a look at what happens if A is between 0 and 1, so a fraction. But just note that not all fractions are less than 1. Some fractions are bigger than 1. Hello. There we go. So if A is between 0 and 1, so 0 less than A less than 1, then G of X is a horizontal. And then now something that's a fraction less than 1 is going to do the opposite. When it's horizontal, it's going to stretch it horizontally. So yes, it will look like it has a less steep slope, but we're comparing it horizontally, so it's the opposite. So horizontal stretch by a factor of 1 over A, just like the other one. So your example for this one, f of x is going to be the same, x minus 1. But g of x is going to be f of 1/3 x. If I write g of x in terms of f of x, what will the new equation look like? Think how we did the other one. We just replaced x with 4x. So what's g of x here? Radha? Yeah, 1/3 x minus 1. I'm just taking the 1/3, replacing it with x. If there's a number in front of x, you just multiply it by whatever the 1/3 is. Okay, now let's go back to Desmos and replace the second equation with 1/3 x minus 1. So you can just delete the 4 and type in 1/3 with the fraction symbol. Oops. So yes, from the looks at it, it looks like it is compressed, but it's actually stretched horizontally. And how do I know that? Because y-intercept stays the same, and because if I do compare the y values here, this is 0 and that's 2. That's not being stretched by a factor of 3. So it doesn't work vertically, it only works horizontally. So I would take my line and I stretch it out away from the y-axis horizontally. The y-axis. Or is that what you were asking? Oh, well, yes. And then all the points would be 3 times further away. So, like this point is at 1, this point's at 3. This point is at 2, this point's at 6. this one is at 3. What's this one now? 9. 3 times further away. So here the factor would be 3, which is the reciprocal of 1/3. So let's go back to our notes. We're done with the Desmos, so you can close your Chromebook. And we will describe it as G is a horizontal stretch by a factor of 3. And remember, also, anytime you say compression, the factor should be something less than 1. Anytime you say stretch, the factor should be something bigger than 1. So it makes sense that if this is compression, then the factor is 1/4. Stretch, then the factor is 3. This is why I'm letting you use your notes on your quiz, because it can get a little bit confusing with the different terms. I'm thinking Friday. At first, I think the week at a glance says Thursday, but I'm thinking Friday. Probably be better. Okay, so let's do some examples. You're going to go to the last page because we did the other 4 examples from yesterday on this page. And if you were here yesterday, we're not really going to use this blank graph. Maybe at some point, but probably at this point, I think we're not going to use this. I'm just going to print off some notes for you for tomorrow. Okay. So on the back of your page at the top, what I would do is write horizontal examples. That way you don't get confused with yesterday's on the previous page that was the vertical examples. And we're also only going to graph the first one because I think at this point you guys are pretty good at graphing lines, and I just want to cut to the chase and only do what's necessary so we have time for passing back your test at the end of class. So the first one is f of x equals negative x plus 1. And then your function transformation rule is h of x equals f of 2x. So step 1 is to find the new h of x equation. So I have 2x in the parentheses. That means instead of x, I'm going to write 2x. You still write the negative sign, but you write negative 2x, and then the plus 1 part stays the same. Be careful on your homework for tonight and Edulastic because they're all going to be mixed up. So you really have to pay attention to which type you're doing, if you're doing horizontal or vertical one. So I would definitely have your notes with you when you're doing the homework tonight. All right, let's graph both of those lines. So the first one is at negative x plus 1. So it starts at 1, and it has a negative slope, which means we go down 1 over 1, down 1 over 1, then up 1, left 1. Okay, messed up a point there. And then the other one is negative 2x plus 1. So same y-intercept as you would expect. But now we're going down 2 over 1, down 2 over 1, and up 2, left 1, up 2, left 1. So the reason we know that we need to be comparing this horizontally is because in the function rule, the 2 is in the parentheses. So the 2 is being multiplied by x, which means it's a horizontal transformation, not a vertical one like we did yesterday. So if I look at my red line, I see that the red line is compressed towards the y-axis compared to the black line. So you're taking it and you're squishing the points closer. like this point goes there, this point goes there, this point goes closer, closer, and every point, if you look, it's getting 2 times closer. So this means it's a compression. So for the description, we'll say horizontal compression. By a factor of what? Remember, it's the reciprocal. It's the opposite. Adam, 1/2. So all the points get closer, 1/2 closer to the y-axis. Okay, do the next one. Number 2 is f of x equals 4x minus 2. And your rule is g of x equals f of 1/2 x. We are going to, oh, wait, go back to the other one. I forgot to mention. Again, I would make in your note in your notes that the y-intercept stays the same. Make a note in your notes. Y-intercept. Yeah, either on the front page or just on this side. Y-intercept stays the same. And x-intercept changes. That's because if we're multiplying, if the y-intercept is when x equals 0, and if you multiply 0 times anything, you still get 0. Okay, number 2. So our rule is f of 1/2 x. So I'm plugging in 1/2 x in for this x. So g of x would be, you keep the 4 times 1/2 x minus 2, and then we just multiply the 4 and the 1/2 together, so that would be 2. So g of x equals 2x minus 2. And we're going to skip the graphing the line part. I know that you will, everybody will be eager to graph the lines later today when they're bored, or when you get home, or when you're riding the bus on the way home. But we're going to skip it for now and just describe it. So remember that the 1/2 is in the parentheses, so we would call it a horizontal what? Rada? Yes, a stretch, because the opposite 1/2 would be a stretch it horizontally. Stretch by a factor of, and you take the reciprocal of 1/2, which would be 2. So here's the new equation, and then there's the description of the transformation. Horizontal stretch by a factor of 2. Ready for the next one? Okay, number 3 is f of x equals 3x plus 8, and h of x equals f of 4/3 x. So I'm going to give you a minute head start. Write the new function, h of x, and describe the transformation. So just like how we wrote the other ones. Note, 4/3 is a fraction, but it's bigger than 1. You shouldn't need your calculator for this because the fractions simplify. Okay, so you plug in 4/3 x into x in the equation, and 3 times 4/3 just means the 3's cancel out, and then you get 4x plus 8. Not that the new function really tells you how the transformation is. The transformation is all just based off of the rule that they gave you. So this would be a horizontal. Since 4/3 is bigger than 1, this would be a horizontal compression. What'd you say the factor was? Do you know? Yeah, that's the reciprocal. So by a factor of 3/4. Okay, we'll do one more that is your exit ticket. So f of x equals 3x plus 5, and then h of x equals f of 1/3 x. So write the new function and describe the difference, or describe the transformation. And stay awake. And your homework is an edge elastic. Sorry, but not sorry. There is no check answer button in your homework. So the reason why is you'll kind of see it when you get in there, but I didn't want people taking advantage of the check answer button because there are some questions where, actually I'm going to just, well, never mind. How do I pause this? There are some of the questions that